In this video, I'm going to show you 3 of the problems from the Quadratics Review worksheet, numbers 5, 6, and 7. And when you're solving a quadratic equation, there's 2 different methods that you can use. There's factoring, and then there's quadratic formula. And each method has its pros and cons. Factoring is a nice, efficient way of solving a quadratic equation. However, not every quadratic expression is going to be factorable. Quadratic formula, on the other hand, will work as a method for solving any quadratic equation. However, there's a lot of steps that you have to go through, and therefore there's a lot of room for arithmetic errors. So what we'll do in each of these 3 problems is we'll start by trying factoring, and then if that doesn't work, we'll fall back on the quadratic formula. So the first thing, no matter which method you're going to use, you want to make sure that your quadratic equation is set up in standard form. That is, ax squared plus bx plus c equals 0. And in this particular equation is already set up that way. A is 2, b is 7, and then c is 3. In factoring involves some educated guessing and checking, but there is a systematic approach that we can take that will help us to factor the expression that's on the left-hand side of this equation. And if we can find a pair of numbers that multiply to give us a times c, and that number happens to be 6, that's 2 times 3, and those same 2 numbers add up to give us b, which is 7. And so 2 numbers that will do that are 6 and 1. They multiply together to give us 6. They add together to give us 7. And so what we do with those 2 numbers is we're going to split up this middle term. And so our new equation is going to become 2x squared plus 6x plus 1x plus 3 equals 0. And then if we take a look at the first 2 terms and the last 2 terms, in the first 2 terms we can factor out a 2x. And what we're left with is x plus 3. And I'm going to bring down my plus sign. There's no common factor in the last 2 terms, so I'm just going to factor out a 1. And then what I'm left with is x plus 3. Notice how this first term and this second term here, they have a common factor. Their common factor is x plus 3. So I'm going to factor that out. And then what remains is 2x plus 1. Next, we'll apply the zero product property. The zero product property just says that if you have 2 or more things that are being multiplied together and the result is 0, that means at least one of those things has to be 0. At least one of those factors has to be 0. And so either the factor x plus 3 is going to equal 0, or the factor 2x plus 1 has to equal 0. And to get our 2 solutions to this quadratic equation, we'll just solve each of these individual equations. And so the first one, we'll subtract 3 from both sides and get x is negative 3. So that's one of our solutions. And then in the second one, we've got to subtract 1 from both sides first, and that's going to give us 2x equals negative 1. And then if we divide both sides by 2, we'll get x equals negative 1/2. And so there's our 2 solutions, x equals negative 3 or x equals negative 1/2. In problem number 6, again, the equation is already in standard form. So let's go ahead and try to factor. A, in this case, happens to be 2, B happens to be negative 1, and then C is negative 2. So if we're going to try to factor this, we need 2 numbers that multiply to give us A times C, which is 2 times negative 2, or negative 4. And then we need 2 numbers that are going to add together to give us B, which is negative 1. And so if we list all the different combinations of numbers that multiply to give us negative 4, we can have 4 times negative 1, or negative 4 times positive 1. We could have 2 times negative 2, And then if we take a look what each pair of numbers will add up to, 4 and negative 1 add up to 3, negative 4 and positive 1 add up to negative 3, 2 and negative 2 add up to 0. So none of our combinations give us that sum of negative 1 that we were looking for. What that means is this quadratic expression is not going to be factorable. So our other choice is to use the quadratic formula. And the quadratic formula is this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so then if we substitute in our values, the opposite of b is going to be positive 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 2. And then that's going to be all over 2 times 2. And then continuing to simplify, underneath the square root we'll have 1 plus 16, and that's all over 4. And so x equals 1 plus or minus the square root of 17 all over 4. And the square root of 17 we can't simplify any further, so there's our two answers. Next, in problem number 7, you'll notice that in this equation we don't have a 0 on one side of the equation yet. So the first thing we'll need to do is write it in standard form. And so we can subtract 5x from both sides. We'll get x squared minus 5x minus 14 equals 0. So in this problem, a is 1, b is negative 5, and c is negative 14. So if we're going to start by trying to factor, we need to find two numbers that multiply to give us a times c, and so that's going to be negative 14. And those same two numbers need to add to give us b, which is negative 5. And so if we take a look at some different factors of negative 14, it could be 2 times negative 7, it could be negative 2 times positive 7, it could be 1 times negative 14, it could be negative 1 times positive 14. And so the combination that's going to work is 2 times negative 7. And so we'll use those two numbers to help us split up the middle term. So we can rewrite our equation as x squared plus 2x minus 7x minus 14 equals 0. And then if we group our terms, the first two terms we can factor out an x, and that's going to leave x plus 2. Bring down the subtraction sign. In the last two terms we can factor out a negative 7. And then if we do that, just be careful of your signs here. Factoring out a negative 7 is going to leave x plus 2 in the parentheses. You'll notice how what remains in parentheses should be the same in both. So that if we factor out that common factor of x plus 2, then what's going to remain is x minus 7. So then we can apply the zero product property, either x plus 2 equals 0, or x minus 7 equals 0. That's going to mean x equals negative 2, or x equals positive 7. And next I wanted to show you what would happen if we chose to do number 7 by the quadratic formula instead of factoring. So remember, a was equal to 1, b was equal to negative 5, and then c was equal to negative 14. So once again, here's the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if we substitute in our values, the opposite of b is going to be positive 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 14. And that's all over 2 times 1. And then that will simplify to 5 plus or minus the square root of 25 plus 56 all over 2, which then becomes 5 plus or minus the square root of 81 all over 2. And notice how we had a perfect square. 81 is a perfect square. So that's a clue that this one is factorable. And so we can continue to simplify here. And I'm going to split it up into our two solutions. We have 5 plus 9 over 2, and then 5 minus 9 over 2. 5 plus 9 is 14, divided by 2 is 7. And then 5 minus 9 is negative 4, divided by 2 is negative 2. And we got the same two solutions as we did when we factored. Now, if you feel as though you need more practice with solving quadratic equations, you should try the remaining problems on the review sheet, because we will expect that you'll be able to apply your knowledge of quadratic equations when you see them come up in some geometry problems.